Okay, in this session we're going to discuss using integers as exponents. Alright, and before we get to any problems, what we want to do first is just go over a couple of properties. So we'll list those out and I'll give you some examples. First property, b to the n times b to the m. Alright, so this is saying you have a power here, that's to the exponent of n, a power here to an exponent of m, but the bases of the two powers are the same. So when you have a situation like that, you get an answer of b to the n plus m. Alright, so in other words, if the bases are the same, you just add the exponents. And an example of that would be something like, let's say, x to the third times x to the fifth. Since both of the bases are x's, your answer will have x for the base, and you would just add the 3 and the 5, and you would get 8. Okay, so that's an example of the first property. Second property is saying you have a power being raised to some exponent. Okay, so you have your power inside of the parentheses, b to the n, and it's being raised to some exponent m. Okay, and when you have a situation like that, now you actually multiply the exponents. So an example, x to the second raised to the, let's say, to the fourth would be x 2 times 4, which is once again 8. Alright, so in this case, because this exponent is inside of the parentheses being raised to another exponent, then you multiply the exponents. Alright, third, you have two products being raised to, well, excuse me, let me give you the property before I give you an example. A times b, alright, a times b raised to the n exponent. And what they want you to understand is that these two products, the a and the n, are being raised to the same exponent. So that's like distributing the exponent amongst the products, okay, amongst the factors of this product. So a gets raised to the n and b gets raised to the n. Okay, so an example, let's say 2x to the third. Okay, so we have 2 times an x. 2x is like saying 2 times x, and both the 2 and the x are being raised to the third power, or an exponent of 3. So that's like saying 2 to the third and x to the third. And we know 2 to the third is 8, so that would be 8x to the third. Alright, and now instead of multiplication, if we look at the same principle in the form of division, okay, so you have a quotient here, a divided by b, and both of them are being raised to the n. Then again, it's like distributing that exponent. So it would be the equivalent of saying a to the n over b to the n. Okay, so let's say we have 2 over x to the fourth. That would be like saying 2 to the fourth over x to the fourth, and we know 2 to the fourth is 16 over x to the 4th. Okay. And then number 5. 5 comes with a couple of conditions. Alright. So we'll say 5a. Okay. And this is going to be a situation where you have b to the n over b to the m. Okay. So a quotient situation where the base is the same but being raised to two different exponents. Alright. So since the base is the same, since both have a base of b, the answer will be b to the n minus m, as long as n is greater than m. So as long as the exponent n is greater than the exponent m, then you subtract n minus m and you'd write the answer as the exponent. So let's say we had x to the 5th over x to the 3rd. Alright, we have the same base of x. Okay, so since the base is the same, the answer is going to be x, and it's going to be 5 minus 3, which is 2. So your answer will be x squared. Okay, 5b. Same situation, b to the n over b to the m. Alright, in this case we're going to now say that it's going to equal 1, and this happens when n is equal to m. Alright, so you have the same base, and in essence, since n is equal to m, you have the same exponent, and so they will basically cancel each other and just leave you with 1. Example being x to the 4th over x to the 4th. Right? N and m are the same. Your bases are the same. So it'd be like saying these cancel and just would give you 1. Alright? 5c. Once again, b to the n over b to the m. Now here we're going to say we're going to get 1 over b to the m minus n, and this is the case when m is now greater than n. Alright? Now m is greater than n, so when m is greater than n, or your exponent in the denominator is greater than your exponent in the numerator, you do your subtraction and you write your answer in the denominator. Okay, so an example, x to the 2nd over x to the 7th. Alright, same base, both have the base of x. This x in the numerator is raised to the 2nd, x in the denominator is raised to the 7th. So you would say 7 minus 2, which would give you 5, but because your bigger numerator, your bigger exponent is in the denominator, then you'd write that answer in the denominator, x to the 5th. So 1 over x to the 5th would be your answer. Alright? So basically the following problems we're going to do in this session are going to be a fallout from using one of these 5 properties. Okay. Let's look at one like, say you have x squared times x to the negative 5th. Now it's important that you understand anytime you have a negative exponent, you can change its position within the fraction, because any integer or any term can be written in fraction form by writing it over 1. So I could say this is like saying x squared over 1. It's like saying x to the negative 5th over 1. And again, anytime you have a negative exponent, all you do is change the positioning of that term in that fraction to make it positive. So since x to the negative fifth is in the numerator, I can make this negative fifth positive by turning it into 1 over x to the positive fifth. Now, so I took this and brought it down into the denominator, which made my 5 now positive. My exponent is now positive. So now, when I multiply, I end up with x squared over x to the fifth. Okay, same base, different exponents. The bigger exponent is in the denominator. We just talked about this. So your answer will be x 1 up top, because you're going to write your answer in the denominator, and 5 minus 2 gives you a 3. So x to the third. Write this a little bit better for you. Alright, so 1 over x to the third. You wrote your answer in the denominator again because you had the bigger exponent of the two in the denominator. Alright, let's look at another one. Let's see, let's look at one like this. Let's say we have x squared y to the negative third all to the negative fourth. Okay, now two ways you can do this. You can go ahead and set this up to where you take care of this negative exponent inside of the parentheses and then distribute the negative 4, or you can go ahead and distribute the negative 4 up front. So I'm going to go ahead and distribute the negative 4 up front. So I'm going to multiply all exponents by negative 4. So that's going to give me a x to the negative 8 and a y to the positive 12. Alright, and as I explained, every term can be written in fraction form by writing it over 1. And anytime you have a negative exponent, you can change the positioning of that term in the fraction to make it positive. So because I have x to the negative 8 and that's in the numerator, I can just bring it down to the denominator and make it positive. So that would look like 1 over x to the positive 8 and y to the 12th, still over 1. Okay, so then you have y to the 12th. When you multiply across, 1 times y to the 12th is y to the 12th. X to the 8 times 1 is just x to the 8. Alright, so your answer is y to the 12th over x to the 8th. Let's look at another one. Let's say we have one like 3 x squared y to the negative 4th times 4 x to the negative 3rd y. Alright, now we're doing some actual multiplication here. You have a 3 times a 4, that's going to give you a 12. Alright, you have x squared, x to the negative 3, you have y to the negative 4, y to the positive 1. Personally, I suggest before doing the multiplication that you set these up so that all the exponents are positive. So when I look at this first one, this is really like saying that over 1 and that over 1. So I could rewrite this as 3x squared, and because my y to the negative 4 is in the numerator, I can write it in the denominator to make it positive. Alright, and here, because my x to the negative 3rd is in the numerator negative, I can bring it to the denominator and make it positive. So now this is what I'm looking at. So 3 times 4 would give me 12 x squared y over y to the 4th, or let me put the x's before the y's. You want to try to make a point of writing the variables in alphabetical, in alphabetical order. So now I have this. Alright, now I have x to the 3rd and x squared. same base. The denominator exponent is greater than the numerator exponent for the x. So these will cancel and leave me 1 there. And my y, same base. This is a 1, this is a 4. So that 1 will cancel and leave me with a 3 here. So I end up with 12 in the numerator. And in the denominator I have x to the 1, which is just x, y to the third, which is y cubed. Okay, so 12 over x y cubed would be your answer. Alright. Let's look at another one. Let's say now we have 12 a to the third b squared over a negative 3 a to the negative 1 b to the fifth. Okay, now everything other than this a to the negative 1 is in positive exponential form. Alright, I'm not worried about this negative 3. This negative 3 is an integer. I only worry about the negatives when they're attached to exponents. So this is all I'm worried about right here. I'm not worried about this negative 3, only worried about negatives that are attached to exponents. So in this case, because my negative exponent term is in the denominator, I move it up to the numerator, and I would get this. Now if I move this up, it becomes a to the positive 1. Alright, and leave everything else as it was. Okay, so my negative 3 is still on the bottom, b to the fifth is still on the bottom, my 12 a to the third is still up top, my b squared is up top, but now I moved this and put it right there up top. Now it's a positive exponent. Now I have same bases, so I can add my exponents. So that gives me 12 a to the fourth, because 3 plus 1 is 4, b squared over a negative 3 b to the fifth. Okay, now I'm looking here, b's over each other, greater exponent is in the denominator, so I'll subtract. These two will disappear, knock this 5 down to a 3, because 5 minus 2 is 3. Alright, so now I have 12 over negative 3 a to the fourth b to the third, and I deal with my 12 over negative 3, which gives me a negative 4, and I keep my a to the fourth in the numerator, my b to the third in the denominator, and there's your answer. Alright, so a negative 4a to the fourth b to the third. Okay, let's look at this one. This one would be a good one to try. We have 15 x to the negative 1 y squared over 5 x y to the negative 4. Alright, y to the negative 4. And this is all being raised to the negative 1. Okay, so for me, go ahead and distribute that negative 1 to everything. Right, and it also includes distributing it to constant terms or integers. Alright, it's not just applying to variable term, but you have a 15 here, so that negative 1 gets tacked on to this 15, but it also works for the denominator as well. So it's going to get tacked on down here for this, and for this. So now you have 15 to the negative 1 x to the positive 1, because negative 1 times negative 1 is positive 1, y to the negative 2, because 2 times negative 1 is negative 2. In the denominator, you're going to have 5 to the negative 1, because right now anytime you just see a number, it's like saying that term, that constant is just raised to the first power. So 1 times -1 is -1. My x is now to the -1, and my y is now to the +4, because -1 times -4 is a +4. Alright, at this point I want to move everything to get all my exponents positive. So I want to move this down, I want to move this up, I want to move this up, and I want to move this one down. So now I have 5 to the first, x to the first, which is this one. Then I have another x to the first, which is this one that I just moved up. Okay, so I move that up, and already had that there. Okay, now in the denominator I have 15 to the positive first, because I moved this one down. Alright, and I have y to the fourth, because it was already down here, didn't need to move. And then I have y to the positive second, which is this one that I moved down. Alright, same basis, add exponent, same basis, add exponents. So now what I'm looking at is 5x squared, because 1 and 1 is 2, over 15 y to the 6, because 4 plus 2 is 6. Alright, so at this point I can deal with my 5 over 15, which is, if I pull out a 5, can be reduced by 5. Pull out a 5 out of 5 is 1, pull a 5 out of 15 is 3. So what you end up with is 1x squared over 3 y to the 6, right? 1/3 is 5 over 15 reduced to 1/3, and we know we don't write 1 unless we don't have anything else in the numerator or anything else accompanying it, so we simplify to make it look like this: x squared over 3y to the 6. That would be your final answer. Alright. Okay, so that was basically multiplication and division as far as dealing with positive and negative or just integer exponents, and how to make them positive and simplify the expressions. Okay, now let's look at how we would deal with these same scenarios if it was addition and subtraction. So we're looking at 2 to the -3rd plus 3 to the -1st. Okay, now you may be tempted when you see this problem to go ahead and add the 2 and the 3 and then combine the exponents, but you don't do it that way. When you're talking addition and subtraction, you want to deal with each individual term first. So I want to take this 2 to the -3rd, which is like saying 2 to the -3rd over 1, and this 3 to the -1st, which is like saying 3 to the -1st over 1. Bring that down to make my exponent positive. Bring that down to make my exponent positive. So now what I'm really looking at is 1 over 2 to the +3 plus 1 over 3 to the +1. And because these are numbers, we can actually calculate what 2 to the 3rd would be, which would be 1 over 8, and 3 to the 1st is just 3. So now we're looking at a situation where we're really trying to add 1/8 plus 1/3, and we know when we're trying to add fractions you need a common denominator. So in this case we choose 24 to be our common denominator. 8 goes into 24 3 times 3 times 1 is 3. 3 goes into 24 8 times 1 is 8. So now I have a common denominator, 3 plus 8, 11 over 24. Alright, so there's your answer there. Let's look at another one. Let's look at, let's say we have 4 to the negative 1 minus 3 to the negative 2 all to the negative 1. Now before, we would distribute that negative 1 in all the problems we did before when we were doing multiplication and division. But now, because we're doing addition and subtraction, we don't want to do this distribution. Alright, we don't want to do that. What we need to do is just like we did the last problem. We need to address these negative exponents on the interior first and write these in their proper form. So I need to bring this down, bring that down. So really what I'm looking at is 1 over 4 to the positive 1 minus 1 over 3 to the positive 2 raised to the negative 1. Alright. So here simplifies 1/4. 4 to the 1 is 1/4 minus 3 squared is 9 to the negative 1. I have to find a common denominator. What is that going to be? 36. Alright, so 4 and a 36, 9 times 9 times 1. 9 and 36, 4 times 4 times 1. Still to the negative 1. 9 minus 4 is 5 over 36 to the negative 1. Now that I've gotten rid of the subtraction, it's just a single quotient. Now it's a division problem. I can distribute my negative 1. So what this is really like saying now at this point is 5 to the negative 1 over 36 to the negative 1. And we said we adjust the positioning to change the exponents from negative to positive. So to make the 36 to the negative 1 positive, I write it up above. And to change the 5 to the negative 1 from negative to positive, I write it down below in the denominator. And anything to the first is just that thing, so 36 over 5 is your final answer. Alright. 36 over 5, 36 fifths is your final answer. Okay. Let's try one more. Let's see. So we have a to the negative 1 plus b to the negative 2. Alright. Again, that's like saying a to the 1, 1 over a to the first, and 1 over b squared. Okay, in order to add these fractions, we have to get common denominators. And when we're talking variable denominators, we need to try to get whatever we're missing from the other denominators. So I have an a in a denominator, but I need a b squared. So I need to multiply this by b squared over b squared. This denominator has a b squared, but it's missing that a. So I need to multiply by an a over an a. So now I have b squared plus a. 1 times b squared is b squared. 1 times a is a. And it's all over a. Here's our a. B squared. Here's our b squared. So ab squared ends up being our common denominator. And again, this is an a, not a 9. It's an a. Alright? These are a's. There are no numbers in this problem. They're all variables. So you have b squared plus a, here I'll write it like that, over a b squared. If that helps out any. And this would be your final answer. Alright, so that's a quick lesson in learning how to do various operations, multiplication, division, adding and subtracting when dealing with integers for exponents. So in other words, your exponents can be positive or negative, and how to deal with those situations. Alright, if there are any questions, feel free to contact me. At this time, we will now conclude the session.